Hello everyone, this is John with Ziptopia.org. Welcome to the RFC 3261 Simplified series, part 6. In our previous tutorial, we covered the method cancel in great detail. So let's move on to the register method. So far, our sample calls have been between Tarzan and Jane using either SIP proxies or back-to-back user agents in between. Let's use registrations from a call with SIP proxies and a call with a back-to-back user agent to go over two different samples in order to understand the concepts better. So in our SIP proxy call, a repro SIP proxy is sitting at IP address 192.168.1.15. Jane has the username Jane, and the system allows calling by username instead of extensions, and she has the IP address 192.168.1.14. For the back-to-back user agent call, the asterisk now PBX is the back-to-back user agent and has the IP address 192.168.1.3. And in this call scenario, Tarzan has the extension 55555 and he is at IP address 192.168.1.20. As we briefly discussed in RFC 3261 Simplified Series Part 1, when a user fires up their phone, there must be a mechanism to let themselves be known to others. There's no point in having a phone if you are not going to be able to call anyone, and no one is going to be able to call you. While the users can be manually added to the environment, the automated way to do this is using register requests. Let's quickly go over some important points about register requests that will help us with the following sections of this tutorial. We will revisit these during the course of this tutorial. They are listed here just to be used as a quick reference in the future. Register requests are processed by registrars, a type of user agent server. Registrar binds address of record and contact addresses for the user. Address of record and contact addresses can be compared to user and devices user can be reached at. Address of record is in to header field, whereas contact addresses are in contact header field. Address of record is long-term, contact addresses are short-term. Address of record can only use SIP or SIPs in URI, whereas contact addresses can also use other device types like tel, mail to, and so on. Registrar uses location service to store these bindings. These bindings can also be added manually, which is not a part of our scope as we are working on register requests. Registrar and location service are logical entities, not physical. So they could reside in SIP proxies. Moving on to the constructing register section, first of all, it is worth noting that a register request can be used to add, remove, and also query bindings. As far as how the register request is constructed, we have already covered this process in RFC 3261 Simplified Series Part 3 under the section called Sending Requests. As you may recall, once the request is constructed, an existing route header field is the first place to look at to figure out where to send the request to. Record route header fields, on the other hand, should be ignored for register requests and responses. In other words, when talking about register request, don't ever use it and record route header field in the same sentence. Going back to RFC 3261 Simplified Series Part 2, a SIP message, either request or response, has to have a start line and a message header. Even though we know the generic purpose of a request URI, and certain header fields, let's give them a closer look from register request perspective. The request URI basically dictates the domain we are trying to register to. In the case of Tarzan and Jane, since we didn't have DNS servers, request URI dictates the IP address of the domain. Well, the former goes through the DNS resolution process to figure out the IP addresses anyway. Please note that in register request, the URI does not have a user portion or an @ symbol. Once again, the request URI dictates the domain we are trying to register to, not an end user or a resource we are trying to reach. That's why it doesn't have a user portion or an @ symbol. Now let's go over the header fields. As we mentioned in multiple tutorials before, the following 6 header fields are mandatory for every SIP messages, whether they are requests or responses. To, from, C-sequence, call ID, max forwards, and via. Similar to the request URI, from register request perspective, to, from, C-sequence, call ID, and the optional contact header fields are worth taking a closer look at. From to and contact header fields perspective, earlier we made some references to address of record and contact header field values. Let's revisit them real quickly. Address of record and contact addresses can be compared to user and devices user can be reached at. Address of record is in to header field, whereas contact addresses are in contact header field. Most of the time, the from header field value will be the same as to header field value. However, it is worth mentioning that the from header value could be different than the to header field value if there is a third party involved. Basically, the to header field value is the party we are registering, whereas from header field value is the party responsible for the registration. That is why, unless a third party is involved, we will mostly have the same to header field and from header field values. Now, some folks might find this interesting, which would help them remember it better. Every call ID header field value in register requests that a specific user agent client sends to a specific user agent server should be the same until the user agent client is rebooted or restarted. We know that the call ID values are globally unique for each dialog. In other words, the call ID header field value must stay the same until a call is terminated and no other call in the future could use this same value. The key point here is that the register requests do not create dialogues. As a result, the call ID header field values do not have to change for different register requests, provided that they are between specific user agent client and user agent server. Alright, so if the register requests between two specific user agent client and user agent server are the same, in an IP world, how do we know if the requests and responses are received in correct order? Well, this is where the C-sequence header field comes to play. Each time a user agent client sends a register request, it has to increase the C-sequence header field value by 1. That is how the user agent client and user agent server know the order of received requests and responses. As you can see here, while Jane's SIP phone sends register request to its SIP proxy with the same call ID header field values, the C-sequence header field value is increased by 1 in each register request. This is register request 2. This is register request 3. And this is register request 4. Similarly, Tarzan's SIP phone sends register request to its back-to-back user agent with the same call ID header field values, but increases the C-sequence header field value by 1 each time a request is sent out. So this is register request 2, this is register request 3, and this is register request 4. Unfortunately, all good things come to an end, and registrations are no exceptions. When a user agent client sends a register request, it may define an expiration for the registration. There are two ways a user agent client could define an expiration for a registration. First way is using contact header field parameter expires. By using a contact header field parameter, a user agent client can actually choose different expiration values for different contact addresses. Alright, today's too detailed or unnecessary information of the day is that the expires parameter can be up to 2 to the power of 32 minus 1 second. Any value higher than this would be considered 2 to the power of 32 minus 1 seconds, and this is equivalent to 136 years. Well, if the expires parameter value is malformed, by default, 3600 seconds should be used. The second way for a user agent client to define an expiration for a registration is, if an expires parameter described earlier is absent, using expires header field. This could not be more confusing, so let's spend a little more time to make sure it's clear. So there are two entities in question. One is a header field and the other is a parameter in a contact header field. Both are called the same, but the header field naturally is written in capital letters, expires, whereas the header field parameter is written in small letters, expires. To understand why expires parameter is preferred over expires header field, let's consider an instance where Tarzan is going to register his cell phone and his chat client in his PC. Well, he probably would like to have the registration of his cell phone to last longer than the chat clients, as he will be moving around the jungle a lot with his cell phone, and it is simply inefficient to send register requests over and over again instead of using a rather higher expiration. In this scenario, if Tarzan uses expires header field, it will be applied to both the cell phone and the chat client. Expires header field cannot be used for one entry and not for the other. On the other hand, since he has two contact header field entries, one for the cell phone and one for the chat client, Tarzan could use two different expires parameter in contact header field values to define two separate expiration. That is why, logically, expires parameter in contact header field is preferred over expires header field. It is also worth noting that the user agent server might be configured to accept only expiration values higher than a certain number. If neither expires parameter nor expires header field exist in a register request, user agent client is simply asking the user agent server to decide on the expiration value. The user agent client sends register requests periodically before the expiration of the entries to refresh the entries if it chooses to do so. The procedure is the same as the procedure we have just described in the expiration of entries section. As we have mentioned a few times already, a register request may have more than one contact addresses in the form of contact header field values to bind them to an address of record located in the to header field. We also talked about giving them different expiration values in the expires parameter as a part of the contact header field. Well, how about preference? If we are registering our chat client email address and the SIP soft phone, do we want them all to receive an invite at the same time if someone is trying to reach us? It is certainly possible, and it is called forking, which will be covered in the following tutorials. But what if we want to be reached at our SIP phone first, and if we are busy or unavailable, we want the invite request to be sent to our chat client address, and if it all fails, we want the invite request to be sent to our email address. As you may recall from RFC 3261 Simplified Series Part 3, there is a method to give preference to different contact header field values. A register request may have a contact header field that could include a Q value with each contact address indicating its priority. The higher the Q value is, the more preferred the contact address is. For example, if Jane sends a register request with the following contact header field, that means she prefers to be reached at Camp 3 first, and then Camp 2 if she is not available in Camp 3. Damn it, Jane has to leave Camp 3 for an urgent meeting in Camp 2, but she doesn't want to leave her Camp 3 device available. There were some problems in the past that someone would answer other people's phones, pretending to be them, and ultimately steal their identity. A lot of folks have suffered and their credit scores hit bottom. Anyways, in order to remove her Camp 3 contact address from the registrar, Jane sends another register request with this specific entry in the contact header field and either an expires parameter in the contact header field or an expires header field with the value of 0. Well, what if Jane has, as described in an earlier example, a chat client, an email address, and a SIP softphone installed in her PC, all registered, and she wants to simply unregister them all? She could certainly follow the procedure we have just talked about and send separate register requests for each entry to remove them individually. That would be extremely inefficient though. Jane could simply use a special value just valid for contact header fields, an asterisk, and the expires header field value of 0. Please note that we cannot use the expires parameter here, as we are looking at this from a more global point of view. It has to be the expires header field. Whether you add or remove registration entries, a successful register request results in 200 OK response from the registrar. The single most important point about this 200 OK response, in my humble opinion, is the contact header field values. As we mentioned earlier, contact header field is not mandatory. However, 200 OK response to a register request is an exception. More importantly, this contact header field lists all the contact addresses associated with that address of record. And this is the back-to-back user example. Going over all these registration examples, we have added entries, removed entries, and then added more, some entries expired, and so on. How does a user agent client know which entries are still active? In other words, how do we know which contact addresses are there attached to our address of record? Let's come to a logical conclusion to answer that question. Contact header field is not a mandatory header field. We know this from an earlier tutorial. We now know how contact header field is used to add or remove contact addresses. Therefore, if we use a contact header field in our register request, we will either add or remove entries. And the response will be 200 OK in any case, providing the most current list of contact addresses attached to our address of record. Well, if we send the register request with no contact header field, we won't be adding or removing any entries. The response will still be 200 OK, providing the most current list of contact addresses attached to our address of record. A 200 OK response could also include a date header field which, as the name implies, provides date and time from the user agent server. A user agent client may use this header field to set its internal clock. So we have been discussing the register request, but what good is a register request without a registrar? Well, we take it for granted when we start a SIP phone that it has all the configurations in place and has the registrar to send the register request to. Obviously, this configuration requires prior knowledge of the registrar. There are two ways the user agent client could actually reach a registrar without prior knowledge of it. First one is an approach we could figure out by logic. Just like a person joining a new group of people, a user agent client may not know anyone but itself. Therefore, a user agent client would certainly know its address of record, just like a person would know their name. From earlier discussions, we know that the address of record can be found in two header fields. We also know that the difference between two header fields and the request URI is that request URI does not have the user portion and the @ character. Therefore, indirectly, we now know the request URI. In RFC 3261 Simplified Series Part 3, we discussed where to send the request to if we have no prior knowledge of the next hop, which would be the registrar in this case. Obviously, we would not have a route header field since the user agent client is not configured with the registrar address. Therefore, we look at the request URI to decide where to send this register request to. Since we know the request URI based on the conclusion we just came to, that's the address of our registrar. If this address is a domain name, which it is most of the time, user agent client uses DNS to resolve it to an IP address. The transport layer protocol and the port are extracted again by following the procedure we discussed in part 3. The second way to discover a registrar without having prior knowledge of it is using multicast. The concept of multicast is not in the scope of this tutorial, but we could quickly get familiar with it here. If a network entity A wants to send an IP packet to network entity B, A sends the packet out with the destination IP address B. This is called unicast. If a network entity A wants to send an IP packet to everyone in the network, let's say B, C, D, E, and so on, it would use the broadcast IP address of the network. The important point is that each entity in the network gets an IP packet. This is what broadcasting is. If a network entity A wants to send an IP packet to a group of people in the network, let's say B and C only, and not the rest of the network, obviously broadcasting is not the solution. Broadcasting certainly would get the IP packets to B and C, but also to the rest of the network, which is a waste of bandwidth and, in some cases, a security problem. Unicast could also be used, but in that case, A would have to know the IP address of B and the IP address of C. When the list of people in the group is much higher than 2, this becomes extremely inefficient. What network entity A does to send an IP packet to a group of people in the network is using multicast. Entities B and C would register to a multicast group that is assigned an IP address from the multicast IP address range, and entity A would use that IP address as the destination. This way, only one packet is sent out to the next hop, and if there are multiple entities subscribed to the multicast group this hop can talk to, it creates that many IP packets and sends them out. This creates a branch-like structure and it is the most efficient way to talk to a large group of people in a larger network. Going back to the discovery of a registrar, a user agent client could send the register request to the all SIP server's multicast IP address 224.0.1.75 to reach a registrar. A registrar in this scenario could respond to this multicast with a 302 moved temporarily response and provide its unicast IP address in the contact header field for the user agent client to use in order to reach it directly. Alright, we have constructed our register request, we discovered a registrar to use, and we send out our register request. What happens when the registrar receives it? First of all, we know the initial procedure a user agent server follows to process requests independent of the type of the request from RFC 3261 Simplified Series Part 4. Let's take a closer look at the processing now from register request perspective. Okay, let's say we are a registrar and we have just received a register request. Is the domain in request URI a domain we are configured to be responsible for? If yes, move on to step 2. If no, are we co-residing with a SIP proxy? If yes, well, just let the SIP proxy forward the request. If no, this register request has failed. Step 2. Is there a require header field? If no, move on to step 3. If yes, do we support all the listed extensions? If yes, move on to step 3. If no, this register request has failed. Step 3. Are we configured to authenticate the user agent client? If no, we may use the from header field as asserted identity and move on to step 4. If yes, we can proceed with the authentication. Do we have an authorization database? If no, move on to step 4. If yes, is this authenticated user authorized for the respective address of record? If yes, move on to step 4. If no, this register request has failed. Step 4. Is the domain from the to header field, the address of record, the same, or does it belong to the domain in the request URI? If yes, move on to step 5. If no, this register request has failed. Step 5. Is there a contact header field? If no, skip step 6 and move on to step 7. If yes, is there a special character asterisk and an expires header field? If no, move on to step 6. If yes, are there other entries in the contact header field, or is the expires header field not 0? If yes, this register has failed. If no, this is for a removal. Do we have a binding with the same call ID? If no, nothing is added or removed. If yes, is the C sequence higher than the last register request? If yes, this is a valid removal. Remove the entry or entries. If no, this register has failed. Step 6. For each address in the contact header field, is there an expires parameter in the contact header field? If yes, that's the expression value requested. Move on to step 7. If no, is there an expires header field? If yes, that's the expression value requested. Move on to step 7. If no, user agent client leaves the expression value decision to user agent server. Move on to step 7. Please note that the user agent server may or may not use these expression values. Just because we request a certain expression value doesn't mean user agent server will agree to it. Step 7. We, the registrar, respond with 200 OK, and list all the contact addresses available for this address of record in the contact header field. Alright, we have covered the register request in detail. If you have any questions or comments about this tutorial, please let us know. Thank you.